Uh, Thank you everyone for joining for the August webinar of the Geohealth Early Career Committee. We are very excited today to have Dr. Yuji Shi, who's a postdoctoral research fellow at the Gangarosa Department of Environmental Health, which is within the Rollins School of Public Health at Emory University. And so we'll hear all about all the research between climate change and dialysis patients. But before we get started, I will just have some brief housekeeping items. We'll have a presentation by Dr. Shi, followed by a moderated question and answer. And so we ask if you do have a question, please just submit it to the chat to the person who is labeled as ask questions here, and we will collate them together and I will ask them on your behalf. And by default, your audio and video is turned off, and for bandwidth, please keep your audio and video turned off during the duration of the presentation. And with that, I will stop sharing my screen. And Dr. Shi, if you would like to share, please go ahead.
Okay, let me see. One moment. So, everyone seeing my screen fine? My slides?
Looks great.
Great. Okay, so I will start. So, first of all, thank you very much for inviting me here to give the talk. As Alison have introduced, my name is Yuji Shi, and currently I'm working at Emory University Rollins School of Public Health as a postdoctoral research fellow. And today I'm going to talk about my research, actually two of my projects that have been done on the subject of climate change and the dialysis patient in the United States. So here's the outline of today's talk. So I will start with the personal introduction on my educational background and a brief introduction to on my research interest. And then following that, I will start talking about my research. I will start with the background and introduction, and there are two major parts of today's talk. The one is the wildfire smoke PM2.5 study I've done on dialysis patient, and this study has been already completed and published. And the other part is on the extreme heat event effect among the specific population as well. And this part of the project is ongoing, so I will share some of the preliminary results with the audience. And I will conclude with the discussion and conclusion. And following that, as Alison has mentioned, there's going to be a Q&A session at the end. Okay, so first of all, a really brief introduction of where I come from. So I graduated with both major in biology and environmental science from Dickinson College in the year of 2014. And after that, I went to UNC Chapel Hill and I got my MSPH and PhD degree in epidemiology. And I graduated from UNC Chapel Hill last summer. So I have been in Emory for almost a year, and I have enjoyed it so far. And for my research primarily focuses on climate change associated health outcome assessment. And broadly, I have interest in environmental epidemiology. My work primarily focuses on right now on air pollution and extreme weather or extreme temperature events. And I also have an interest in epidemiological methodology study. So that's a brief introduction of me personally. And so I will start to talk about the two projects I'm going to share with you today. And so climate change are related to a series of extreme weather conditions or events, including hurricanes, flooding, droughts, wildfires, and temperature extremes. And for today's talk, things that have been worked on the two major events. So I will be focusing on wildfires and temperature extremes. And starting with wildfire. So as many of you may already know or have experienced by yourself personally, that there are more wildfires incidents in the US currently, and the fire season is getting longer, and the fires are resulting in greater area burned compared to historical records. And wildfire events pose threat to public health not only by direct burning, but also by generating smoke plumes contains extremely high levels of air pollutants like particulate matter. And this smoke plumes is especially dangerous because the smoke plumes can spread or can travel to a really long distance. So even though people may not experience the fire by themselves, but they could be exposed to the smoke generated by fires thousands or hundreds of thousands miles away from them. So that's why wildfire smoke PM2.5 is considered to be extremely dangerous for public health. And the other climate change related event that I'm interested in is this temperature extremes. In today's presentation, I'm going to talk about extreme heat event. So in the US, extreme heat event is are also increasing in frequency, duration and intensity. And if you're paying attention to recent news, you can see there are a lot of heat warnings going on around the state. So that's also a growing threat to public health, and the human body need to maintain a certain temperature to function well. And extreme heat events are really dangerous for the people who are especially vulnerable or with pre-existing conditions. So those are the two events that I have conducted, or I am still conducting research on, and those two events will be the focus of today's talk. So the population of my study are dialysis patients, and because they are potentially vulnerable population. And why I wanted to study vulnerable population, because they are usually the sentinel population for emerging or new exposures like climate change related events. So traditionally, vulnerable populations, including children, elderly, and people with pre-existing conditions. And dialysis patients fall into the definition of people with pre-existing conditions. So by definition, dialysis patient in my study, I focus on hemodialysis patient who are relying on dialysis treatment, in-center dialysis treatment to survive. And they're all renal failure patient. So by definition, they lost 85 to 90% of their kidney function, and they need to go to the in-center dialysis treatment 2 to 3 times a week. So that's a lot of commitment for them. And almost all of the hemodialysis patients in the US have other pre-existing conditions, including diabetes and cardiovascular diseases. And dialysis patients are known for their high cardiovascular disease risk and the mortality rate. So their annual mortality rate in this population is around 19%. So about like 1/5 of them will die annually. So that's a really high mortality rate. And on average, hemodialysis patient in the US go to are being admitted to hospital 2 times a year. So that's a really high number too. And this population is also large and keep growing. You can see in the plot, in the down right corner, the blue line pointed by the right pointer is showing the number of hemodialysis patients in the US. So currently, in the year of 2018, there's almost 500,000 prevalent hemodialysis patients in the US, and the number is predicted to keep increasing because of high rates of obesity and diabetes and aging population and the scarcity of organs for kidney transplantation. So that's why we are interested in this population, and because they're particularly fragile and the number is large and keep growing. So, okay, that's good. So for the study objectives, so for the wildfire study, we aim to assess the association between daily smoke PM2.5 exposure and mortality among U.S. kidney failure patients who receive in-center hemodialysis from the period 2008 to 2012. And for the extreme heat event study, we aim to assess the association between extreme heat event exposure and health outcomes among the same group of patients, but during the different time period of 2011 to 2016. So I will start to talk about the methods applied for the wildfire study. So for the wildfire study, we used a time series analysis on the county level, and we included U.S. counties, contiguous U.S. counties within 200 kilometers from a large fire origin point. So from this map, you can see those red triangles marked those large fires that occurred during 2008 to 2012. And when we're talking about large fires, we mean the fires that have resulted in the area burn equal to or greater than 50,000 acres. And so the study areas are the 627 U.S. counties within this buffer, and the study population again is all patients residing in the study counties based on their dialysis clinic address with Medicare as primary payer. And for the exposure assessment, so how we measure the smoke PM2.5 level as so by definition, the exposure of interest for this study is the county level daily wildfire smoke PM2.5 concentration in the unit of microgram per cubic meter. And we used the data from CMAC modeling. So this is emission and chemistry atmospheric model, and we use two runs. So the difference between two CMAC runs give us the wildfire smoke PM 2.5, which equals to the total PM 2.5 minus the non-fire PM 2.5. And for the outcome assessment, the outcome by definition is the daily county level in-center hemodialysis patient death count. And we focused on both the total and by place and the cause-specific mortality. And for that, we used the data called US Renal Data System, which is USRDIs, which has a nearly complete inclusion of all US dialysis patients. So in the US, basically all dialysis patients are covered by Medicare, and their information are collected by this USRIS data system. So moving on to statistical analysis. So we used quasi-Poisson regression model adjusting for time varying factors, controlling for an upside to study the association between wildfire smoke PM and daily county level mortality. And with this model, we are trying to estimate how many changes in daily mortality counts are explained by changing in smoke PM 2.5 levels on the county level. And the time varying confounders we control for daily county level non-fire PM 2.5, heat index, and depth of peak and calendar days were included to control for temporal trend and seasonality. And we have this offside variable called modality, which is used to as the denominator to estimate rate. So for the lag effect, we used the model called distributed lag model with the same set of covariates. So that's a brief description of the methods used in this project. So now I'm moving on to the result for the wildfire study. So this is a table summarizing the baseline characteristics of the study population. So overall, a total of 48,000 patients died during the study period within the study area, and the average age at dialysis initiation was 65 years old, and 45% of the study population were female, and white was the largest risk group, accounts for about 73% of the total population. And catheter was the predominant access type used at dialysis initiation, and diabetes and hypertension were the most common primary cause of end-stage renal disease in our study population. So this is a brief introduction of the study population, and for the exposure distributions, I have these two maps. So map A is showing you the number of days with wildfire PM 2.5 contribution above 10 microgram per cubic for each of the counties within Sentinel hemodialysis clinic near fire. So for both of the maps, the counties with gray colors are the counties without dialysis clinic. So we're not showing that exposure here. So the map B is showing the average wildfire PM 2.5 concentration on days with wildfire PM 2.5 concentration above 10 microgram cubic meter. So it's showing that for the distribution of exposure varies across different counties, and different counties exposed to wildfire smoke for different lengths of time during the study period. So for the outcome, a total of 48,454 deaths were included. And among those, about 40% occurred in non-clinical settings, which are home, nursing home, other are missing. And about 60% of them occurred in clinical settings, which are hospitals and dialysis clinics. And also looking at the total number of deaths by the biologically plausible primary cause of death, about 40% of the deaths were cardiac-related death, and 40% of them were with other causes, which are other, unknown, and missing. So we can see there's a lot of death with unidentifiable cause, because in this data, the cause of death is not from the standard NDI database, but it's from this form called CMS 2746 death notification categories. So the quality of the cause-specific death classification is questionable with all these missings. But we still look at the effect by place of death. So first of all, looking at the association, we look at the all-cause mortality effect. So here's the rate ratios and 95th percentile confidence intervals for total all-cause mortality, all-cause non-clinical mortality, and all-cause clinical mortality. And for total all-cause mortality, we observed a rate ratio of 1.04 for immediate effect, which is a like day zero effect, and slightly higher ratios range from 1.05 to 1.07 for cumulative lagged effect. And for death occurred under non-clinical settings, slightly higher ratios were observed, and for deaths occurred in the clinical settings, lower and non-significant rate ratios were estimated. And the total mean effect observed for the total all-cause mortality is primarily driven by the deaths that occurred under non-clinical settings. So the hypothesis here is that we suspect that the deaths, the people who died at non-clinical settings have a higher effect estimate, because the non-clinical settings has a probably worse filtration systems, which means they are exposed to more smoke PM compared to the people who stayed in clinical settings where there are better filtration system or better environment. So that's why that's what we suspect behind this difference of effect by place of death. So even though we don't really have a great cause of death recorded, but we still do assess the potential modification by cause specific death. So in this plot, the black star point marks the ratio estimate for all cause and cause-specific mortality occurred in all places, and the red round dots represent ratios estimate for mortality occurred in non-clinical settings, and the blue triangle dots for are for the mortality occurred in clinical settings. So when looking at the effects by primary cause of death, the total all-cause effect observed is primarily driven by the deaths with other causes. So that's basically telling us there's the problem of the quality of the cause of death recorded, but for the future study, we may need to find different sources for the cause of death to further understand this potential association by cause-specific endpoint. So we also calculate the attribute fraction. So for all cause mortality on this with wildfire PM 2.5 over 10 microgram per cubic meter fire accounted for about 8.4% of daily mortality. So this is the final conclusion result for this project. And this study has been published in Journal of American Society of Nephrology. So if you're interested, please check it out and let me know if you don't have access to it. I can send you a free copy. Yeah. And so that's it for the wildfire study. I will change the topic a little bit and talking about the ongoing study I'm doing on extreme heat event. So for this study, again, the study area is contiguous United States, and the study period is from 2011 to 2016 with the latest available USRDS data. So after I'm done with the wildfire study, the USRDS released the new data. So we are doing analysis with the new data right now. So for the study design, we utilized a time and geographic location stratified case crossover study design on the zip code level. And the study populations are patients residing in the study region with Medicare as primary payer again. So for the exposure assessment to measure and define extreme heat events on the zip code level, Dr. Han and Dan Lu from Emory, Liu's group, processed daylight data and extracted daily maximum and minimum temperature information for the study region for the time period of 1980 to 2016. And in this study, extreme heat events were identified during warm seasons like May, which the warm season is defined to start at May and end at October. And first, we calculate unique calendar day of the year and location-specific 95th percentile threshold from the prior 30 year of daily maximum temperature. And then daily maximum temperature for the specific study zip location from 2011 to 2016 were compared with their respective calendar day and location specific threshold and assigned a value of 1 if the maximum daily temperature exceeds that threshold. So that's how we define our extreme heat events. And this method has been used in other in previous epidemiology study as well. So, so for this study, we are not only interested in the mortality effect, we are also interested in the effect on hospital admission and ED visits. So things from the last study, we learned that for this group of patients, for this specific data source, the cause-specific mortality may be not a good outcome to study. So in this study, we only studied all-cause mortality effect, but for hospital admission and ED visits, we have diagnostic code that enable us to study the cause-specific hospital admission and ED visits. And for that, we studied the all-cause CVD events And we also studied a subgroup of the CVD events, which are dysrhythmia disorder and heart failure. And in addition to CVD endpoints, we are also interested in this outcome called fluid electrolytes disorder. So this is more particularly related to this heat exposure, and also which is a pretty specific outcome for dialysis patient because their kidney is not function, and so they by nature they are not good at fluid electrolytes balancing. So for statistical analysis, since this is the case crossover study design, so we use the stratified conditional Poisson regression. And in the model, we actively control for the time varying confounder of daily zip code level relative humidity. And for the strata, we use the day of the week, month, year, and this CBSA regions to define the strata of comparison. And for the linkage of outcome and exposure, this is based on the last dialysis clinic visited before each event. So that's the method used in the extreme heat event analysis. And so now I'm going to share some of the preliminary results on this project. So for this study, we incorporate events from 670,000 hemodialysis patients, and among which about 43% are female, and the average age at dialysis initiation was about 62 years old, and the primary race composition were white, and the second large race group, race and ethnicity group was Black. And again, diabetes is the primary reason for kidney failure, and about half of the included patients are having cardiovascular disease at dialysis initiation, and over half of them are having diabetes at the start of the hemodialysis. So during the study period, we identified over 600,000 days as days with extreme heat events, and that's on average for each zip code experiences 17 extreme heat events day per warm season or per year. So here's the model estimates for extreme heat event effect. So in general, we are seeing higher effects for ED visits and hospital admissions, but no effect for mortality. And we have also assessed the potential lag effect and found that for the extreme heat event, the same-day effect is the predominant effect. And this trend holds for all of the outcomes assessed. And furthermore, we are also looked at the potential effect measure modification by climate regions. So the contiguous United States can be classified into 9 climate regions. We used the NOAA definition. And so here are the different panels showing the regional differences. So we are seeing some regional differences, but some of the differences are just not statistically significant. So we're doing more analysis on that, and that's all the result I have so far for the extreme event analysis. So our studies, of course, have some strengths and limitations. So for the strengths, our studies are the first of this kind of study, and we studied a potential susceptible population, and the access to USRS database give us a near complete representativeness of the study population, which is pretty unique, and we really appreciate that. And for the limitations of just like all environmental epidemiology study, there's the potential of exposure misclassification because personal exposure are basically impossible to be measured on the personal level. but we believe in the models we choose, and we have tested for them. So this is the best we can have for now. So in conclusion, both wildfire smoke PM2.5 and extreme heat events exposures are associated with adverse health outcome among US dialysis patients, and our results highlights the need for research to understand the impact of climate change related events in different populations and to develop and implement interventions to manage these emerging exposures. And for the next step, so I'm planning to study other climate change related events like hurricanes, drought, and fires. So instead of studying fire smokes, I'm also interested in studying the fire itself, its impact on different populations. And I'm also interested in studying this similar effect on additional outcomes like the interruption of dialysis treatment, which is the big threat for hemodialysis patient, especially this in-center hemodialysis patient. And also in the longer or in the far future, I'm hoping to expand this kind of study to other potentially vulnerable populations. So here's my acknowledgement. So I have carried this project from my my PhD program at UNC to Emory, and this is also a collaboration between EPA, and I also worked at EPA as an ORES fellow on this project, and I would like to thank everyone who's involved. Yeah. So this is my acknowledgement, and this is the disclaimers of today's talk. So I'm good for questions, and here's my email. If you have anything, you can just feel free to shoot me an email and ask.
Amazing. Thank you so much for providing all that information, results, methods about those two really fascinating studies, and also for providing your contact information if folks have questions. But I will remind everyone, it's in the chat if you joined late. We have a participant that's been renamed to ask questions here. Please feel free to direct message that participant and we'll collate the questions and I'll ask them on behalf. But I will start off with one question. For you mentioned and the conclusion for this last study that your results can help inform interventions. I was just curious, like if you, in a perfect world, if you could just like go to these places or go to the outpatient facilities, what can, you know, either from the patient side, the clinician side, or even as a researcher, would you maybe suggest we could do to help? Okay. Like what interventions would you suggest from like any perspective?
Okay, so I think we have, because on our like team, we have like clinicians from the UNC Kidney Center, so we have talked a lot about like what's the next step. So what is the so what question? So what we have like thought that we could do with this kind of study result is like to inform the at least in the dialysis clinics, like to ask them to inform their patient that during maybe during the day when there is a smoke PM2.5 or PM2.5 level in general, one day the PM2.5 is pretty high, please try their best to stay indoors. And this kind of like just let me think of the wording. I think it's first to make them to make them be aware of their surrounding and pay attention to the air quality I think measurement that is available on everyone's smartphone, and also to react accordingly to that. So that's one thing they can do. So it's this like educational intervention is the first step. And later on, we have also done other like studies like on biomarkers. So the effect of PM2.5 on biomarkers. So that's more like it's applicable to the clinician part, which is when they're saying their measurement is high or low, then they can then the relevant treatment can be given to the patient. So that's the, I don't know if that's the like the intervention you're thinking of, but I think that's the like kind of like the first step is the educational intervention. Just let them be aware of their surroundings. If there's a high pollutant day, or if there's a high temperature day, just be aware and take precautions and be prepared. Also be prepared for those events because they are getting more and more frequent. Yeah.
Thank you so much. So another question that we have from the audience is thank you, excellent presentation. Do you see the same effects on dialysis patients in response to wildfire PM2.5 compared with PM2.5 from other sources? Or is that still an active area of research?
I think it's already answered that. So I think it's an active area of research because right now we are trying really hard to differentiate small PM2.5 versus PM2.5 from other resources. But the thing is, like from IP study, we only have the measurement in the mass, so in the concentration of PM2.5. And we don't really have the resources to differentiate PM 2.5 from different sources, as PM 2.5 is a mixture. So we're doing work to first generate the exposure assessment for different kind of PM 2.5, and then with that we can use that in a more IP study to tell the if there is a difference actually, if the difference actually exists or not. So that's ongoing research. Yeah.
Thank you. So I know that you mentioned the challenges on the side of sort of like I would say more like geography, sort of like atmospheric science. I'm curious as to what challenges, because I know you saw in like there was the table of like unknown cause of death, it's just not in the database. Are there any other challenges you experienced in using sort of the health data sets?
Yeah, so I think the health data set is not so for this, for my example, my experience with USRDS is the data set is not designed to be used for this kind of study. So you always get like a raw data and you need to work it through. You need to learn what each variable means and how the data is constructed. And sometimes, I don't know how many of you have worked with Medicare data. It's pretty complex in terms of the construction, and to get the data ready for this kind of IP study to be linked with the environmental exposure is always the first step, and for me it's always the hardest step to get the data right. So I think this is one of the difficulties and the first difficulties, and surprisingly people don't really talk a lot about it, but for me, for my dissertation, I use this data for my dissertation as well. I spent basically like I think half of my data processing time to just get the data right, just get the data the way I want it to be. So I think that's the biggest challenge once you have access to data. And also getting access to this kind of data is also hard because these data are expensive and there's the concerns of confidentiality, breakage, and there's a lot of DOAs you need to sign. So as you can imagine, it's pretty hard to hold on to it as well. So I think those are the two big challenges using this data. One is to get to the data. Second is to get the data make the data the way you want it. Yeah.
Thanks. That's super helpful, especially for early career audience, having like a realistic expectation. Like if you're on the Geohealth and maybe you're more atmospheric science and you want to go into epidemiology, having a realistic expectation of it's hard to data wrangling and all that. That's super helpful from you sharing your experience there. So we move on to another question from the audience. Do you think income or occupation play a role in both effects of wildfire, PM 2.5, and heat? This person says they're thinking that some people will not be able to avoid exposure by staying home on extreme PM 2.5 or heat days, may not have air conditioning, and will therefore be more exposed or affected.
Yeah, I think that's a definitely valid point, and especially for the general population, people with different income, different occupation, they will not be able to respond to this kind of event as ideally. The thing is, for this specific study population of dialysis patient, because their healthcare is like fully covered by Medicare, based on my understanding. At least the cost of their dialysis treatment are covered by Medicare. So we are not seeing a lot of we did look at some of the potential modifier by occupation and income, but we just don't see a strong modification in this specific population. And also because you can see at the start of dialysis initiation, the average age is already around like 62 years old in this population, and in the previous wildfire study population, it's around 64 years old. So most of them are already like retired in this specific population. So we didn't really see huge modification by occupation or by income in this kind of analysis. And also I have to state that we don't really have direct information of income in the USRS database, so we use surrogate for that. So maybe that's the surrogates are not very good to show that, but we just don't really observe a lot of effect measure modification by those factors. But in the general population, definitely, yeah.
Awesome. Thank you so much for that response. I'm going to switch over to asking more like general questions about your career, your path. Thank you so much for sharing those beginning slides about your education and your interest. I think it's super helpful. But I guess I'll just start off with a short question, but also very broad. Do you have any advice that you wish that you had received when you were starting your career, or even like, I want to apply to grad school, you know, what made you choose UNC? What made you choose Dickinson? You know, any sort of advice you can share with the audience.
Okay. I think it's pretty broad. Let me start with some small points. So what made I choose UNC is because like I took one IP class, not really IP class, called environmental health class at Dickinson, and the professors gave just like one introduction lecture on epidemiology, and I really liked it. So I pursued that interest, even though that's just one or two lectures. I think that's enough for me to switch my interest. And you can say from my undergrad experience, I was interested in biology and environmental science, which is totally different from epidemiology. But just keep an open mind for anything, and don't hold on to your believe the personal interest too tightly. There's different things out there, maybe you just don't know. So that's a kind of like first thing I hope I knew when I was in college, because I was like really focused on biology and environmental science. And when I took this class in my last semester of my senior year, I was like, oh, there's a whole different world out there. I just don't know about it. And so yeah, keep open mind. That's really important. And other things I would like to know is like before my dissertation, I think the other thing is that just don't assume your dissertation should be, or your doctoral whatever master program should be perfect. You just keep going, and you will get to the point where you are, even though you may not find the perfect project to work on, you may not get the perfect result, but just keep going and you will get to the point you want. And yeah, that's the thing I wish I could knew.
Thanks for sharing. I think it's really helpful to hear, to be open to opportunities, and then also when you have them, have some perseverance, trusting yourself. I think that's something that we can always all hear, and really like that you've internalized that and you can share that with us. So another question that I have is, you worked with, especially in the second study, a lot with other collaborators. You specifically call them out. And I know in your first one too, you had a lot of co-authors on your paper. From the perspective of being someone who's on a transdisciplinary team, what advice do you have for early career researchers who might not have those relationships yet, where it's maybe just their advisor or their supervisor working on a project together? What would you want from the perspective of someone who maybe when you were writing your paper, like having more people on the team, or now in your position, if you're bringing someone onto your project, what qualities are you looking for in a good teammate?
Okay, yeah. I think, yeah, I have worked with people from different background. I think a good teammate is someone who's always being open and being okay with the things that they don't know. So for example, I work with a lot of like clinicians. So the clinicians, they are really busy. So they don't know a lot of epidemiology. So then I'm looking for someone who are comfortable with the unknowns. So they're some of people just not really comfortable with the things they don't know, and they will be offensive, and they will be defensive when we are talking about things they don't know. So I'm always looking for the people who can deal with the unknowns and to just live with it. So sometimes I don't think to be honest, my collaborators, I don't believe they understand epidemiology 100%, but I do trust in their specialties and they trust me in my specialties. So, and they're okay that they don't know 100% about epidemiology. So I'm always looking for that kind of collaborators. And the other thing is also someone who's interested in the topic you are interested in. So for all of my collaborators, they're interested in climate change. They're interested in understanding climate change's health impact among certain populations. So I'm also looking for the people who share the same interest. Yeah. So I think that's a two big. Yeah, that's the two major features I'm looking for when I'm looking for collaborators. Yeah.
Excellent. Thanks so much. I think we'll have one or two more questions, and always a big one, especially with the academic year starting again for all of us who are on that calendar. Do you have any work-life balance strategies, either ones that you implement yourself or maybe aspirationally?
I don't know. Work-life balance, I don't know. It's really tricky. And I personally, I don't think I maintain a good work-life balance. And what I do is like I would just like, when I have time, I would just try my best to relax, but I don't relax enough, and I don't get really enough sleep. But I wish I can have some time to catch up. So I don't know. I don't think I'm the good person to ask for this kind of work-life balance. Otherwise, sorry.
That's okay. For most people who we ask that question to, it's a very similar answer, but always trying to be better. I think
Yeah,
that's the
I'm
lesson
trying.
here.
I'm learning as well.
That's great. I think so. Like the last question, I think that I just want to ask is: you mentioned future studies that you want to do, looking at different outcomes, looking at different natural disasters as well. Thinking about your career, where do you want to be in about 10 years' time?
Oh, wow.
Or tomorrow. You can say also say tomorrow.
Yeah, I think in the long run, I like to stay in academia if I can, secure a position, and so I will look for academia positions like in big universities where there's the platform for me to continue my work on climate change related health effect. So that's like my really long overarching goal, and the short term, I'm trying to start writing my first proposal. So yeah, I'm looking for collaborations as well on that. So that's my short-term goal is to start writing my first grant proposal. Yeah.
Excellent. Thank you so much for your time, your presentation, sharing your life advice and also professional advice, and all the exciting research you're doing. We really thank you for your time with all of that. And so now I'm going to transition a bit just to closing remarks. Here we have, just to plug it for everyone here, AGU is in full swing as well in the planning session. So we do have, as part of this webinar that Dr. Shi was part of, this is a part of a regular series. I just shared the webinar email sign up link in the chat. Generally, they occur every second Friday of every month, 2 p.m. Eastern, 11 a.m. Pacific time. We have talks like from Dr. Shi on from early career scientists, as well as professional topics like writing grant proposals and science communication. And we also ask that you consider becoming an AGU member if you're not. This webinar is free and open to everyone, and we always intend them to be, but you can also consider becoming a member, and you can join the Geohealth section, which is what we're part of. And with that, I just want to thank everyone for their time. Join us for the next webinar in September. Follow Twitter, AGU, you'll get information there. And I hope that everyone has a great weekend, and we'll see you at the next one.
Thank you, Allison.
Thank you, Dr. Shi.